Hello and welcome to Algebra 2 with Mr. Clausen. Today we are going to look at the quadratic formula. And specifically what we're going to do is we're going to look at a couple different examples of where we can use the quadratic formula. We'll start with how we use the quadratic formula to find real solutions. We'll talk about how to use the quadratic formula with imaginary solutions, which is, I think, one of the most useful applications that we can use the quadratic formula for. We'll look a little bit on how we can analyze the discriminant of a quadratic formula to find a solution type, which we'll talk about that. That's when you find real or imaginary type solutions and you identify that they're present. And then we'll also look at a real world application of the quadratic formula, how we can use it, how we can set it up, that type of situation. So that's what we're getting into today. To get started though, I want to look at how we use the quadratic formula to address real solutions. So if you haven't seen the quadratic formula in a while, this is it right here, all right? So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you notice these a, b, and c values, they are referencing the coefficients of a just normal quadratic equation in standard form. So if you remember, in our earlier video, we talked about this idea that the standard form of the equation is ax squared plus bx plus c, and we're going to set it all equal to 0 because this equation takes advantage of the zero product property. So what we're going to do is we're going to look at the x squared. We see that the coefficient associated with the x squared must be 1, so a is equal to 1. We look at the x term here, and we see that an 8 is associated with it, so the b has to be equal to 8, and the 12 here is our constant, which is our c term, and that is equal to 12. So these coefficients that we just determined here are all going to get plugged in to this quadratic equation we have over here. So if you want to find the solutions of a quadratic equation, and you want to use the quadratic formula to do it, what you'll find is that x is just simply going to be equal to negative, we have 8 for b, so we'll plug 8 in for the b, plus or minus the square root of 8 squared minus 4 times 1 for a and times 12 for c, and then it'll be all over 2a. Or in this case, let's just plug in the 1 here, all right, because that's our a term here. So this is your standard quadratic formula, and we've plugged in the coefficients of this quadratic equation. So now let's simplify this out a little bit. So let's start over here, and let's actually start kind of breaking this down a little bit. So let's kind of simplify out as we go here. So negative 8 plus or minus the square root. 8 squared is 64. And 4 times 1 times 12 is 48, and there's a minus sign, so it'll be minus 48, all over 2 times 1, which is 2. All right, so we're just kind of simplifying everything out. And with this, now all you have to do is you have to solve this quadratic equation. So we'll go negative 8. I'm going to keep this part, which we call the discriminant, separate for just a little bit here. So this will be the square root of 64 minus 48 is 16, all over 2. Let's simplify this one more time. Negative 8 plus or minus 4, all over 2. Both negative 8 and 4 are divisible by 2, so let's just rewrite this as negative 4 plus or minus 2. And this is what your x terms are equal to. So your solutions in this particular instance are negative 4 plus 2, which would be equal to negative 2. And the other solution would be negative 4 minus 2, which would be equal to negative 6. So your solutions for this given quadratic are x equals negative 2 comma negative 6, and that would be your solution set for this given quadratic. Now keep in mind that this will always get you two solutions, and the one thing I don't really care about using the quadratic formula for is that if there's an easier way to break this apart, like if we can factor this out, I can pretty easily see how we could factor this out and find given solutions and factor this in a much quicker sense. You see here that this is really, if you break it down all the way, a 5-6 step process where maybe some of the other techniques that we've looked at are a lot quicker, maybe as simple as 2 or 3 steps. So keep that in mind. The quadratic formula will always get you through and get you these solutions here, but there may be a faster way. Now, where the quadratic formula really becomes useful is that if we want to find imaginary solutions, all right, well, this is a very useful situation to use the quadratic formula for, because we can take an equation like this, and let's just bring it over here. And what I'm going to do is I'm actually going to go and rearrange this in the ax squared plus bx plus c equals 0 format. So what I'm going to do is I'm just going to subtract 2x, subtract 2x, add 5, and what I will get is I will get x squared minus 2x plus 5 all equal to 0. And if I take a little look at this, I'll see that a is equal to 1, b is equal to -2, and c is equal to 5. So what you're going to notice here is that once we start getting through this, we're going to notice something interesting. And that is that there is no real solutions for x. So if we actually went and we pulled up the graph like here and look at this, we'll see that when we have this x squared minus 2x plus 5 equation, you can see the quadratic here, and you can see it never touches the x-axis of the equation, which is where your root or your 0 is that you're trying to find. But what you need to understand is that even if a quadratic equation doesn't have any real solutions, it still has to have solutions. And in this case, they are just imaginary. And that's where the quadratic formula really becomes useful. So if we want to find where the solutions are for this equation, even though that they're imaginary, what we're going to do is we're going to plug these terms in to our quadratic equation and solve as needed. So what we'll do is we'll go -2 plus or minus, because b is equal to -2 plus or minus. And what we'll find here is that we'll go -2, we'll square that value, minus 4 times 1 for a, 5 for c, all over 2 times 1. And we just need to crunch out some of these numbers. So let's rewrite it over here. So -2 would just be +2 plus or minus -2 squared would be 4 minus 4 times 1 times 5. With the negative there, that'll be -20. And we'll go all over 2. Now, what makes the solutions imaginary, what you're going to notice here is when you take the 4 and subtract 20 from it, what you're going to have is that you're going to have 2 plus or minus the square root of -16. And just like we talked about with complex numbers, this is an imaginary component here. There's the square root of -1 times the square root of 16. So we can simplify this out. We can say 2 plus or minus 4i. And all I'm doing here is I'm breaking this apart. I'm saying the square root of -1, which is equal to I, and the other component would be the square root of 16, which would be equal to 4. And we get this, we divide it all by 2. And since 2 and 4 are both divisible by 2, we can just simplify this out as 1 plus or minus 2i. And that would be your final solution. And actually, I wouldn't even write them out separately because of the format that we have here. I mean, technically, it's 1 plus 2i, and x equals 1 minus 2i are your solutions. But feel free to just write them in combined format in this situation, 1 plus or minus 2i. And those would be your solutions for this given quadratic. So even though that there isn't any real solutions, there are still these imaginary ones. And if you plug these into the binomials, you could actually FOIL it out and get this equation back. So that's where they become really useful and where they crash out from. So one of the things I want you to keep in mind when we're doing these type of problems is you might be looking at, well, when do I want to use the quadratic formula and when do I not want to use the quadratic formula? And I would say, as long as you're not going to have a really weird solution or it's not going to be an imaginary solution, I would look at the factoring techniques and the other things that you've learned about in this course if you're taking Algebra 2. So if you are looking at something like this and we say, hey, A is equal to 2, B is equal to 1, and C is equal to 28, what we can do is we can use the discriminant of the quadratic formula to go and determine what type of solutions are present. So the discriminant is actually just this part right here. And the discriminant's going to be what determines whether your equation has real solutions or imaginary solutions. And what you need to keep in mind whenever we're looking at this and we're trying to figure out whether something has a real solution or not is we need to look at if b squared minus 4ac is greater than 0, then what this is going to tell you is that there will be 2 real solutions. And what I mean by that is that if you graph it, it will cross the x-axis twice whenever you have this situation. Another circumstance that you can have is b squared minus 4ac is equal to 0. Now, if this is equal to 0, this whole quadratic is equal to 0, and it'll be negative b over 2a plus or minus 0. So what this means is that when you are looking at a quadratic equation that has a ba squared equal to 0, what that's going to look like is it's going to be an equation where just the vertex barely touches the x-axis. So what that means is that there will only be one real solution, but it'll have what we would call a multiplicity of 2. And all that means is that it would be like a perfect square in a lot of aspects. You know, you would have, x minus 2 squared or something like that, given that situation. So it's just going to barely touch. It's only going to touch the x-axis in one point, which would be its vertex. Okay. So just by looking at the discriminant, you can get some useful information out of it. The last piece of information that you want to take into consideration is just the last one, which is what we just saw. So if b squared minus 4ac is less than 0, and in this case, you would have 2 imaginary solutions. And all this means is that whenever you have a quadratic, maybe it looks something like this, where it never touches the x-axis. So there's no values where you have a root or a component equal to 0. So in this specific instance, all we would need to do is if you want to check and see whether this has one real solution, 2 real solutions, or 2 imaginary solutions, is you just plug in the discriminant. So let's test it here. So if we plug 1 in for b, and we go 4 times 2 times 28. Without doing any real math here, I can very quickly see that this quadratic will have a very large negative number and that 2 imaginary solutions would be present for this quadratic. So it's just a tool to have in your back pocket whenever you're going and you're trying to figure out, hey, what type of situation are we looking at? Or is there even any real solutions? That might be where the rubber really meets the road. And I want to show you that in this next example. So a real world application might be something like this specific word problem that I have here. So the equation h equals 80t minus 16t squared models the height h feet in seconds t by a toy rocket propelled straight up from the ground. Okay, so we have the ground, you know, you are here, and you are setting up this rocket, all right, and you shoot it up in the air and propel straight up from the ground, and we're just kind of taking a look at it here. And this equation, this parabola, is modeled by h equals 80t minus 16t squared. Now, one of the questions I want to ask is, will the object, or the rocket in this case, ever reach a height of 95 feet? Well, how do we actually look at this, and how do we apply what we just learned to this given scenario? Well, what you can do is that you can use this piece of information right here. We can plug it in to the quadratic that was given to us and create this new equation. 95 for the feet equals 80t minus 16t squared. And what we can do is we can put this in standard form, and then we can use the techniques that we just learned. So for example, you know, what I would do is we could just move this to the other side. There's nothing wrong with that. Okay, and we could rearrange here. So take this equation, because these will cancel, right? And we're just going to put this in standard form. So negative 16t squared plus 80t minus 95. And since we canceled that, that would all be equal to 0. And what I just want to ask you as far as this idea is, hey, how can we just verify whether this quadratic will ever reach 95 feet? Maybe the rocket only goes to 90 feet. And we just want to look at how do we just double check? So what you can do is, if maybe the question asks you, will the rocket ever reach that high? Kind of like how I have it phrased here. Well, to make sure if it ever even reached that high, let's check the discriminant. Let's go b squared minus 4ac and see if it's greater than 0. So in this case, remember, a is equal to negative 16, b is equal to 80, and c is equal to negative 95. And if we plug that in here, we're going to get 80 squared. That gives us a nice big positive number. That's nice. And then we're going to go 4 times negative 16 times negative 95. And if you punch this out, you'll get 6,400 minus 6080. And what you'll find is that the discriminant will be equal to 320. All right, so this tells us there's going to be 2 real solutions. All right, this is good. We wanted to know this. And if you actually graph the given equation, all right, this is the actual graph for the equation, h equals 80t minus 16t squared. You start at 0, 0, at 2.5 seconds. What you're going to see is that it reaches a maximum of 100 feet, which fits the parameters that we're looking at, and then it drops down to 0 after 5 seconds. Okay, so we can visualize it and we can see that this occurs, which is another method that you can use. So you can see right up here, all right, that, you know, it's going to cross right there and right there. And let's just find what those values are. Let's use the quadratic formula and let's go and apply this to our given scenario. So we can say x, and remember that 80 is our b value, so we'll go 80 plus or minus. Now, what I'm going to do here is I already found the discriminant. You know, it's at 6,400 minus 6080. So I'm just going to plug the discriminant that we've just found. We don't need to do all that again. And then we're going to divide this all by, let's see, this is negative b, sorry, 2 times negative 16. And let's just start plugging it through and checking it out. So if we have this, we'll say x is equal to negative 80. Let's simplify the square root of 320 here. And actually, if we do that, what we'll find is that this is equal to 17.89. So we can say negative 80 plus or minus 17.89 all over negative 32. And again, we can We can split this apart. Let's just do that now. Let's say x is equal to negative 80 plus 17.89 all over negative 32. And let's say x is equal to negative 80 minus 17.89 all over negative 32. And if we go and we solve for the solutions of these, we will find that this will equal 1.94 seconds after it's simplified. And we will find that this is equal to 3.06 seconds after simplification. And if we check in correspondence with the graph here, yep, that matches up pretty closely. Yeah. So those line up with those values really well. So these are your solutions of the toy rocket and when they will reach that value. So I hope you found this video useful. I hope you have a great rest of your day and that you're able to use the quadratic formula to answer the problems that you're looking to answer. Have a great rest of your day. Bye.